August 23, 1942. Luftwaffe airfield, Merville, northern France. The morning mist hung low over the runway as Oberleutnant Armin Faber rolled his Focke-Wulf Fw 190A3 under the tarmac. He had flown 93 combat missions across the Channel, each ending with the same confidence that no Allied fighter could touch him. The Fw 190 was Germany's secret weapon, fast, agile, and deadly. In mocking radio calls to British pilots, the Luftwaffe called it the butcher bird. No one in the Royal Air Force had yet captured one intact. That morning, Faber's orders were routine. Escort bombers over Bristol Channel, intercept enemy Spitfires, and return before fuel fell below 30%. He never made it back. At 26,000 feet, Faber's flight met a pair of RAF Spitfire Vs from number 312, Czechoslovak Squadron. The dogfight was brief and violent. The Fw 190's BMW 801D2 engine roared through the thin air, its radial cylinders pounding out 700 horsepower as Faber rolled his aircraft into a spiral dive. Behind him, a Spitfire's 20mm cannons spat tracers that fell away in a helix of red fire. The German pilot pulled through the clouds, flipped his machine onto its back, and shot his pursuer down with a burst so precise it was recorded in RAF archives as one of the few confirmed kills ever made by an Fw 190 over Britain itself. Then everything went wrong. Faber's compass spun wildly as he banked for home. The horizon was a gray sheet of cloud and sea. The coastline beneath him looked deceptively familiar. What he believed was France was in fact the Bristol Channel. Flying north instead of south, he crossed the Welsh coast and descended over Cardiff, before realizing too late that every radio frequency was silent. No German ground control, no friendly call signs, only static. Out of fuel and disoriented, Faber searched for a flat stretch of land and saw one near Pembrey Air Base, a grass strip belonging to the RAF. He lowered his gear, made a perfect approach, and touched down smoothly. The airfield's ground crew, seeing a German fighter land peacefully on their runway, froze in disbelief. Faber taxied to a halt, cut the engine, and raised his hands. He had just delivered Germany's most closely guarded technological secret to its enemies, completely intact. Her AF mechanics swarmed the aircraft. They had faced the Fw 190 for a year and lost hundreds of pilots to its superior performance. Now they could touch the machine that had outclimbed, outrolled, and outgunned the Spitfire. Squadron leader James Taylor, present at Pembrey that afternoon, wrote later that the sight was like seeing a dragon land in your garden. The German pilot was led away at gunpoint as technicians guarded the fighter through the night. Within hours, London telephoned RAF Farnborough. A flyable Fw 190 had been captured. The order was clear. Do not disassemble. Do not damage. Fly it. Before dawn, a team of test pilots arrived to secure the aircraft for transport. Every detail was documented: engine serial numbers, propeller pitch angles, ammunition loads, even the placement of armor plate behind the pilot's seat. They had no idea that this single machine would rewrite the Allies' understanding of air combat physics. For Faber, the war was over within hours. For the Allies, it had just shifted in their favor. RAF engineers at Farnborough called the plane Air Ministry No. 500. Its first test flight revealed what pilots had suspected but could never prove. The Fw 190 was superior to every Allied fighter in service, faster in a dive, more agile in a roll, and deadlier in its firepower. The captured engine, a BMW 801 radial with a 2-speed supercharger, could deliver near full power even at 25,000 feet, where Spitfires struggled to breathe. The British finally understood how the Luftwaffe had regained air superiority in 1941. What began as one pilot's navigational error would become a technological turning point. The RAF's examination of that machine would lead to radical advances in engine cooling, aerodynamics, and control systems that would flow directly into the development of the Allies' next-generation fighters. Every rivet and airfoil was a lesson in German design philosophy: precision over volume, performance over endurance. Faber had believed he was returning home to France. Instead, he had delivered Germany's crown jewel to the enemy. When interrogators asked if he understood what he had done, he nodded slowly. "Yes," he replied in fluent English. "It is the end of luck for us." It was also the beginning of the end for German air supremacy. And the moment Allied engineers realized the war could be won through science, as surely as through fire. 2 years earlier, in the spring of 1940, Germany's aviation ministry had grown restless. The Messerschmitt Bf 109, the pride of the Luftwaffe during the Battle of France, was reaching the limits of its design. Its narrow undercarriage caused fatal landing accidents. Its inline Daimler-Benz engine demanded constant maintenance, and at high altitude, the Spitfire Mk5 could now match it. The Reichsluftfahrt Ministerium demanded a successor. What emerged from the workshops of Focke-Wulf in Bremen was unlike anything flying in the world: the Fb 190, a short-winged, broad-shouldered machine that looked almost brutish beside the elegant Spitfire. But beneath its blunt nose was something revolutionary: a twin-row, 14-cylinder BMW 801 radial engine that transformed the physics of air combat. Most fighter designers believed only streamlined inline engines could win dogfights. Focke-Wulf's chief engineer, Kurt Tank, disagreed. He wanted an engine that could survive hits and still deliver power. The BMW 801, with its 41-liter displacement, an innovative commando grate, a mechanical computer that synchronized throttle, mixture, propeller pitch, and supercharger settings, gave the pilot an unmatched advantage. While Allied pilots juggled levers and knobs to maintain optimal performance, the German pilot pushed a single throttle. The system did the rest. At 5,800 meters, the FW 190 still produced more than 1,400 horsepower, while its rival, the Spitfire Viv, gasped for oxygen. Tank's design team built the airframe around this powerhouse. The fuselage was rugged and modular, its engine cowling lined with cooling flaps that opened automatically to regulate airflow. The landing gear retracted outward into the wings, providing a wide stance for takeoff and landing, solving one of the 109's deadliest flaws. The cockpit canopy gave superb visibility. The controls were light and responsive, and every surface could absorb damage. Its armament, 2 13mm machine guns above the engine and 4 20mm MG 151-20 cannons in the wings, delivered 40 kilograms of high-explosive fire per second. In 1941, no Allied fighter could match that weight of fire. The first operational FW 190A1s joined Jagdgeschwader 26 Schlegeter on the Channel coast in August 1941. Within weeks, British intelligence reports spoke of a new radial engine fighter of exceptional performance. Pilots returning from combat described being outrolled and outclimbed at every altitude. When the Luftwaffe switched from Bf 109Fs to FW 190As, the balance over France tilted sharply. The RAF's Spitfire Fw squadrons, once the hunter, became the hunted. On the 19th of August 1941, the first combat test confirmed Allied fears. 2 squadrons of Spitfire Vs were ambushed near Le Touquet. Within minutes, 3 British fighters were down. The rest barely escaped. Intelligence summaries described the enemy aircraft as faster in the climb and dive with astonishing acceleration. pilots noted how the Fw-190 could roll twice as fast as a Spitfire, allowing it to flip from defense to attack in seconds. By early 1942, the Fw-190 was devastating RAF operations over northern France. The Luftwaffe called it the Würger, Shrike, a predatory bird that impaled its victims. Between February and July, Fw-190s destroyed 150 Allied aircraft while losing fewer than 30 of their own. The technical edge was absolute. The BMW 801's twin superchargers gave the fighter power even at 30,000 feet, while its broad wings and roll rate made it lethal in low-altitude dogfights. Allied attempts to catch a one intact failed repeatedly. Crashed wrecks recovered from the channel revealed little. Most burned too completely to yield secrets. At the German Air Ministry, production of the Fw-190 expanded frantically. The Focke-Wulf factory in Bremen delivered 250 airframes per month by mid-1942, while license production at Erido, AGO, and Fieseler raised totals even higher. Tank personally supervised frontline modifications, improved cowlings, heavier cannons, new propeller hubs. The aircraft's modular construction allowed field conversions into fighter bombers, reconnaissance planes, and even night interceptors. In the West, it gave Germany air dominance once again. The RAF's daylight raids over France nearly ceased. Reconnaissance photographs from 1942 show Allied bombers rerouting to avoid the channel entirely. Every intelligence bulletin from Fighter Command carried the same phrase: Fw-190A, unmatched in performance. But German confidence hid a deeper truth. The Fw-190's success had bred complacency. German engineers refined, polished, and perfected, but they did not innovate beyond tanks' design. The Luftwaffe believed it had achieved final supremacy, while in Britain and America, engineers were already studying how to surpass it. When Armin Faber's Fw-190 glided to a stop on British soil in August 1942, he delivered not just an airplane, but an education. Every rivet, every cable, every contour held lessons waiting to be read by Allied minds. The Germans had built a masterpiece. The Allies would soon turn it into a blueprint. But the secret wouldn't remain theirs for long. At dawn on August 24, 1942, RAF personnel at Pembrey Airfield still could not believe what stood before them. The sleek gray fighter with the black cross on its wings looked more like a museum piece than a prisoner of war. Mechanics who had spent months repairing Spitfires riddled with 20mm holes now examined an aircraft that was, until hours earlier, the terror of the Channel front. It bore the number 11+2 on its fuselage, markings of Jagdgeschwader. 2. Richthofen. A lone German pilot had landed uninvited on British soil and delivered the Luftwaffe's best-kept secret intact. His name was Oberleutnant Armin Faber, 30-year-old veteran of the Western and Eastern fronts, credited with multiple kills. He sat in an interrogation room, still in his flight suit, cigarette trembling between his fingers. When the British officer asked him what had gone wrong, Faber stared at the table and muttered, "Ich habe England mit Frankreich verwechselt." I mistook England for France. The story he told would later sound almost unbelievable. After shooting down a Spitfire over the Bristol Channel, Faber had become disoriented. His compass had malfunctioned, and cloud cover erased his visual references. Thinking he was flying south to Brittany, he instead flew north over Wales. The coastline looked familiar enough, the estuaries matching what he believed to be the French coast. When he spotted an airfield with a windsock and no anti-aircraft fire, he assumed it was friendly. He lowered his landing gear, saluted the tower, and rolled to a perfect stop. Pembrey's duty officer, Flight Sergeant Jeff Cross, had seen the aircraft descending and assumed it was a damaged Spitfire. Only when the plane turned into the wind did he see the Balkenkreuz on the wings. Grabbing a service revolver, Cross ran toward it. Faber stepped down calmly, asked in perfect English to see the commanding officer, and was immediately arrested. The RAF suddenly owned a flyable FW-190. The chain of command reacted with precision. The aircraft was flown the very next morning by squadron leader R.P. Beaumont, a decorated test pilot, who described it as a machine of formidable capability. Within days, the FW-190 was crated and transported to Royal Aircraft Establishment Farnborough, where the Air Ministry classified it Airmin 500. There, under armed guard and blackout tarpaulins, the most intensive examination of a foreign aircraft in British history began. Engineers recorded every dimension, every control linkage, every weld seam. The engine, BMW 801D2, was measured to the millimeter. It used a single central throttle control tied to a mechanical computer that automatically balanced the fuel mixture, propeller pitch, and supercharger speed. British and American pilots had long wondered how the FW-190 could maneuver so effortlessly at changing altitudes. Now they had the answer. Even the guns were a revelation. 4 20mm MG-151 cannons, mounted in the wings, delivered a staggering volume of fire. Their electrical firing system, rare in Allied designs, allowed tighter synchronization and higher rates of fire. The armor layout around the cockpit revealed careful compromise, just enough to protect the pilot while keeping the aircraft agile. RAF engineers found something else just as remarkable: simplicity. Every major section could be removed within minutes: engine, wings, tail, even landing gear. Each module attached by quick-release bolts, allowing field repairs impossible on Allied aircraft. The discovery shocked Air Ministry analysts. Germany, despite its reputation for over-engineering, had built a fighter designed for rapid maintenance and mass production. Flight tests began in late September 1942 at Farnborough and Boscombe Down. British pilots approached the aircraft cautiously, aware that even small mistakes could destroy a priceless specimen. On the first test flight, Beaumont climbed to 25,000 feet and rolled the aircraft through a 360-degree turn. Its rate of roll, he reported, is twice that of the Spitfire Fw. Its engine response is instantaneous. It is a masterpiece. The reports that followed were classified most secret and circulated only among senior RAF and USAAF commanders. They concluded that the FW-190 outperformed every Allied fighter below 20,000 feet and matched the Spitfire NUM at higher altitudes. In combat, one report noted, the enemy enjoys a decisive advantage in acceleration, roll, and climb rate. Only new designs with higher power and improved aerodynamics will restore parity. For the first time, the Allies possessed not hearsay or combat impressions, but empirical data. The enemy's weapon had been stripped to its soul. What the Luftwaffe believed a tactical edge would soon become an engineering textbook for its enemies. Meanwhile, in Germany, the loss went unnoticed for months. Faber's squadron filed him missing. Luftwaffe command assumed he had been killed over the Channel. No one realized their masterpiece sat in a British hangar, being flown by Allied test pilots. The FW-190 at Farnborough would soon influence nearly every Western fighter program, from the improved Spitfire 9 to the American P-47 and ultimately the Mustang itself. It had arrived by accident, but its capture would alter the mathematics of aerial warfare forever. The British now understood what made the FW-190 deadly, and how to build something even deadlier in return. Inside a sealed hangar at Royal Aircraft Establishment Farnborough, Britain's top aviation minds approached the Focke-Wulf 190 as though it were a specimen from another planet. Mechanics worked in silence, marking every measurement in chalk before touching a single screw. No one wanted to be remembered as the man who damaged the only intact German Fw-190 in Allied hands. Every rivet, every electrical line, every bearing was photographed and catalogued. The fighter was not merely disassembled, it was anatomized. The RAF's engineers quickly realized they were studying something extraordinary. The Fw-190's BMW 801D2 engine was a compact labyrinth of innovation. Its commando turret, the mechanical brain of the power plant, automatically adjusted the propeller pitch, mixture, and supercharger gear without pilot input. The system condensed dozens of cockpit controls into a single throttle lever. British test pilot James Harrison called it the first true engine management computer ever built. It made the Fw-190 a one-handed machine. The pilot could focus entirely on flying and fighting. The radial engine itself defied expectation. Allied intelligence had assumed Germany's new fighter must use a liquid-cooled inline design like the Messerschmitt. Yet here was proof that a radial could outperform the Spitfire's sleek Merlin. The reason lay in forced air management. Engineers traced ductwork through the cowl and discovered a fan-driven cooling system powered directly from the crankshaft. It forced air evenly across all 14 cylinders, maintaining temperature balance and preventing the overheating that plagued earlier radials. The design allowed the Fw-190 to climb hard without losing power, and, equally important, to dive without the fragile coolant leaks that could kill a liquid-cooled engine. RAF observers noted another revelation: ease of maintenance. Each engine section could be detached by releasing standardized clamps. Fuel, hydraulic, and pneumatic lines were color-coded, unheard of in 1942. A mechanic could change the entire power plant in 90 minutes. British and American aircraft often required a full day. German efficiency had produced not just performance, but practicality. The airframe was equally advanced. The wing spars were a masterpiece of weight distribution. Two single-piece beams forged from duralumin, running tip to tip through the fuselage. Engineers tested samples of the alloy and found it stronger than anything in Allied use. The wing itself had a wide chord, low aspect ratio design optimized for roll rate and structural endurance. In simulated combat turns, the aircraft could withstand over 8 Grewar without deformation. Farnborough's aerodynamicists tested the fighter in the wind tunnel. Smoke trails revealed the secret of its agility. The wing root fillets and smoothly fared canopy produced almost laminar airflow, reducing drag far below that of the Spitfire Fw. This was not luck. It was deliberate design. When RAF scientists measured pressure differentials across the surfaces, they realized the Germans had been experimenting with boundary layer control years before the Allies. The electrical systems astonished the British team. Every circuit was shielded against electromagnetic interference, ensuring radios remained clear even during engine ignition or gunfire. The Luftwaffe's combat discipline was evident even in wiring looms. The guns were harmonized through adjustable shims accessible from maintenance hatches, small details that spoke to industrial precision. Reports poured into the Air Ministry and through joint channels to the United States. American engineers at Wright Field, Ohio, received duplicates of the Farnborough findings by November 1942. Among them were detailed analyses of the Fw-190's air intake geometry, exhaust thrust contribution, and control harmonization, information that would soon influence two of America's most important fighters, the P-47 Thunderbolt and the P-51 Mustang. Yet the engineers also saw what Germany had sacrificed for such perfection. The Fw-190's structure, while brilliant, demanded high-quality aluminum alloys, precision machining, and skilled labor. It was a craftsman's airplane. Britain and America were building their fighters as industrial products, simpler to manufacture by the thousands, maintainable by mechanics with minimal training. The FW-190 was superior in performance, but not in scalability. The discovery struck every engineer at Farnborough. Germany was winning battles, but losing the war of production. Flight tests continued through the autumn, RAF Ace capped. Eric Winkle Brown flew 11 sorties in the captured aircraft, testing climb rate, acceleration, and roll at multiple altitudes. It handled like a bird of prey, he later wrote. Beautiful, lethal, efficient. But it demanded artisans to build it. We built our fighters like machines. They built theirs like instruments. By December, Farnborough's final report filled 3 binders, one each for aerodynamics, propulsion, and systems. The conclusions were blunt. The Focke-Wulf 190 represents the peak of German fighter design. Its technical principles must inform future Allied development if air superiority is to be regained. That sentence crossed the Atlantic with diplomatic priority clearance. Within weeks, engineers at North American Aviation and Republic Aviation were studying the report line by line. They recognized in the German fighter not just a threat, but a roadmap. The Allies had dissected the enemy's masterpiece and were already building something born from its lessons. Winter, 1942. Inside wind tunnels at Farnborough and Wright Field, the stolen Focke-Wulf had become more than a prize. It had become a teacher. The RAF's test reports circulated among Allied design offices under tight security. To engineers at North American Aviation, the findings read like revelation. They studied how the FW-190 gained so much lift from such a small wing, how its wide-track undercarriage eliminated the deadly takeoff accidents that plagued the Spitfire and early P-40s, and how its modular structure allowed field maintenance in hours rather than days. Edgar Schmood, North American's chief designer, already had a new aircraft on his drawing board, the P-51 Mustang. But until that moment, the design had not yet reached its final, decisive form. The early Allison-engine Mustang suffered power loss above 15,000 feet. They were fast at low level, but useless as high-altitude escorts. Then came the British discovery. The FW-190's engine efficiency was not just about brute power, but about airflow, supercharging, and drag discipline. The Farnborough data confirmed what Schmood suspected, that the key to performance lay in managing the boundary layer across the wing and fuselage. North American's laminar flow wing, still in prototype, was refined using airflow measurements taken directly from the captured FW-190's root fairings. The British reports also showed how the German fighter's cowling ducts created residual thrust from its hot exhaust, a concept Packard engineers later incorporated into the cooling system of the Merlin-powered Mustangs. Meanwhile, American technicians at Wright Field began replicating the German machine's control harmony. They studied how its ailerons remained responsive even beyond 400 mm, a speed where most Allied fighters stiffened and lost roll authority. Their tests led to modifications in the P-47 Thunderbolt's control linkages, and later to the spring tab system that made high-speed rolls possible in the P-51D. But the most profound lesson came from what the FW-190 lacked: range. The German design had traded endurance for power. Its 1,800-liter fuel capacity gave it barely 90 minutes of combat endurance, perfect for defending Europe but useless for a long-range escort. Allied engineers saw the inverse solution: maintain efficiency, reduce drag, and extend operational reach. By early 1943, the first Mustangs, equipped with Rolls-Royce Merlin, 61 engines, and twin 75-gallon drop tanks, were flying over the Channel, matching the FW-190's speed and surpassing its altitude performance. At Farnborough, RAF Captain Eric Brown noted the irony. Every test we performed against the Focke-Wulf made our own aircraft faster. Its destruction of our pilots became its instruction. The Americans learned fast. Production lines at North American's Inglewood and Dallas plants adopted German-style modular sub-assemblies, wings, engines, control surfaces, all pre-tested and mated in final assembly within hours. What German craftsmen built by hand, American workers built by system. By mid-1943, a new P-51 rolled off the line every 63 minutes. Technological osmosis crossed the Atlantic faster than any convoy. Reports from Farnborough reached General Hap Arnold's office in Washington, where he underlined one phrase: "The enemy's mastery of aerodynamic efficiency must be met with superior production and power plant design." The result was a partnership that transformed Allied aviation. The British-designed Merlin engine, refined by Rolls-Royce and license-built by Packard, married to North American's aerodynamic purity. Engineers at Rolls-Royce borrowed their own lessons from the FW-190 analysis. Its two-speed supercharger proved the value of high-altitude compressor stages. By copying its pressure ratio balance, they improved the Merlin's full throttle height to over 25,000 feet, the exact altitude where the Focke-Wulf had once reigned. When the first Merlin-powered Mustangs arrived at Boscombe Down for testing, RAF evaluators compared their data directly to the FW-190s. The numbers stunned them. The P-51B could climb 1/200 tolerant feet per minute faster, cruise 100 miles farther on less fuel, and sustain full engine power at 30,000 feet, all while matching the German fighters' roll rate. In a single year, the Allies had not only caught up, they had surpassed. By summer 1943, Mustang prototypes began operational evaluation flights alongside Spitfire and Mize. During mock dogfights, test pilot Alex Henshaw recorded a single line in his logbook: "The student has outclassed the master." The lessons of that captured fighter rippled outward through every Allied design office. Republic Aviation reprofiled the P-47's propeller blades using the German engine cooling data, raising climb rate by 15%. Hawker engineers applied similar principles to late-model Typhoons and the new Tempest. Even American ammunition harmonization, borrowed from German methods, the precise gun convergence patterns measured on the FW-190 became standard in U.S. AAF gunnery manuals. By the time Armin Faber's interrogation transcript reached Allied headquarters, the aircraft he had delivered by mistake was already reshaping the war he'd hoped to win. The enemy's secret had become America's blueprint. By the spring of 1943, the skies over Western Europe no longer belonged exclusively to the Luftwaffe. The balance had begun to tilt, not through numbers alone, but through knowledge. The intelligence drawn from the captured Focke-Wulf 190 had changed how Allied pilots fought. Combat reports from that period show a sudden shift in tactics, an almost clinical precision replacing the desperate improvisation of earlier years. American pilots of the 8th Air Force now flew their P-47 Thunderbolts differently. They had learned from Farnborough's analysis that the FW-190's BMW 801 engine lost efficiency above 20,000 feet, so the Thunderbolts climbed higher to 25,000 feet or more and stayed there. When the German fighters came up to intercept, their engines overheated, their power fell, and the hunters became prey. Major Cass Hovey, one of the first American pilots to fly the captured aircraft, had written a simple directive in his evaluation report: "Force the enemy up, fight where his engine dies and yours still breathes." That line became doctrine. Fighter group briefings across Britain began with altitude charts drawn from Faber's aircraft tests. Air combat had become a science. The new Merlin-powered Mustangs arrived that autumn. They carried the lessons of the German design in every panel: aerodynamic cleanliness, harmonized controls, concentrated firepower. Their engines sang above the thin clouds where the Fw-190 faltered. Allied pilots discovered that for the first time in 2 years, they could dictate the fight. On December 11, 1943, north of Bremen, a formation of 12 Fw-190As dove to attack the returning bombers of the 305th Bomb Group. Waiting above them were 8 P-51Bs from the 354th Fighter Group. Captain James H. Howard led the flight. He rolled inverted, dove through 20,000 feet, and came out behind the German formation. 2 bursts from his .650 caliber Brownings ripped through the leader's wings. The Focke-Wulf broke apart in flame. The others tried to roll away, their old defensive maneuver. But the Mustangs followed effortlessly. The same trick that had once saved German pilots now failed them. In less than 5 minutes, 5 Fw-190s were down. RAF pilots flying Spitfire and 09s reported similar results. The captured data had taught them exactly how to exploit the German fighters' weaknesses: avoid turning at low altitude, climb above 20,000 feet, and attack during its heavy control phase above 400 Mph. For the first time since 1941, the Spitfire's logbooks began recording favorable kill ratios again. Luftwaffe field reports told the story in reverse. German pilots complained that enemy fighters now know all our moves. Oberleutnant Josef Pips Priller, one of the Luftwaffe's most respected aces, wrote in his diary, "The Americans do not fall for our rolling scissors. They climb, they wait, they know our weakness. Someone has told them everything." He was right. That someone was Armin Faber. Though he sat thousands of kilometers away in a Canadian prisoner of war camp, unaware of how his mistake had rewritten the manuals of 2 air forces. By early 1944, Allied escort formations stretched deep into Germany. The P-51 could follow bombers all the way to Berlin and back, a distance the F-190 could not even contemplate. Each encounter was a test of industrial endurance. The Luftwaffe threw its finest pilots into the sky, but for every German ace lost, 3 new American squadrons arrived. German intelligence officers began piecing together what had happened. Reports from captured Allied documents revealed that the Farnborough test had exposed the Fw-190's altitude and control limitations. Some in Berlin called it the technical betrayal. But it was not betrayal. It was analysis, method, and replication. The Allied kill-to-loss ratio told the truth that words could not. In 1942, for every German fighter destroyed, the RAF lost almost 2. By late 1943, the ratio had reversed. By mid-1944, it was nearly 4-1 in the Allies' favor. Luftwaffe Command responded by pushing new variants into service. The Fw-190D Dora, with an inline Jumo 213 engine, meant to match the Mustang's high-altitude power. But even as the Dora entered combat, its performance secrets were already measured against the original Faber aircraft still kept at Farnborough. The British tested it, charted it, and issued new counter-tactics before the variant even reached the front lines. For the men in the air, the shift was unmistakable. German pilots, who once roamed above the Channel, now fought desperately over their own cities. American bombers that had limped home in smoke now crossed Germany in tight, shining formations under the silver escort of Mustangs. What had begun as one pilot's navigational blunder had turned into a counterstrike written not with bombs, but with blueprints. The hunters of 1942 had become the hunted, their own creation, now guiding the hands of those who pursued them. By 1944, the air war was no longer a contest of maneuver. It was a contest of production. What began with the capture of one Fw-190 had evolved into a clash between 2 philosophies of warfare: German craftsmanship versus American industrialism. At Focke-Wulf's Bremen plant, teams of precision machinists hand-fitted every control rod, polished every cylinder head, and measured tolerances by feel rather than gauge. Each FW-190 took roughly 25,000 man-hours to complete. The results were exquisite, an aircraft that handled like a tailored weapon. But in Detroit, Los Angeles, and Dallas, aircraft came off assembly lines with the rhythm of heartbeat. A P-51 Mustang required fewer than 12,000 man-hours, and 3 times as many could be built before the Germans finished one. At Wright Field, analysts compared the manufacturing data gathered from the captured Focke-Wulf to Allied output. The numbers read like prophecy. Germany built 19,000 FW-190s during the entire war. The United States built over 15,000 P-51s and 15,000 P-47s in 2 years. Each aircraft faster to build, easier to maintain, and cheaper to repair. Germany's genius had been trapped inside the walls of its workshops. America's genius lay in repetition. The industrial disparity extended beyond the assembly line. The BMW 801 engine that powered the FW-190 required alloys rich in nickel and chromium, metals Germany no longer had. British blockades and bombing raids strangled supply routes. By 1944, half the engines leaving German factories were fitted with substandard steel valves that warped under heat. Meanwhile, Packard's license-built Merlin engines rolled off precision jigs in Michigan, using standardized components milled by machines that never slept. Fuel told the same story. Each FW-190 sortie consumed aviation gasoline, refined from dwindling Romanian crude. Allied bombers destroyed the Ploiești refineries in mid-1943, forcing Germany to rely on synthetic fuel that produced lower octane and poorer detonation stability. The Mustang's Merlin, designed to thrive on 150-octane fuel, grew stronger as the enemy weakened. Strategic bombardment accelerated the collapse. When the Allies turned their bomb sights on the Reich's aircraft industry, they knew exactly what to target, because they had studied the FW-190's supply chain during the Farnborough analysis. Reports identified where BMW built its supercharger gears, where Focke-Wulf forged its spars, and where Junkers manufactured its radiators. By late 1944, nearly every one of those factories had been reduced to rubble. Still, the German engineers refused to stop. They introduced the FW-190D-9 Dora with an inline Jumo 213 engine, capable of 700 km/h in level flight. On paper, it could challenge the Mustang. In reality, it arrived too late and in too few numbers. Production shortages meant Doras were assembled in barns and tunnels by forced laborers, lacking the precision that had once defined German aviation. Pilots complained of faulty wiring, incomplete radios, and misaligned gun mounts. Across the Atlantic, production worked like an orchestra. Women filled the factories, riveting aluminum skins by the tens of thousands. Freight trains carried fuselages from California to Illinois, where engines awaited installation. Every subassembly was interchangeable. Wing sections, landing gear, even entire tails. A Mustang damaged in France could be repaired overnight using parts shipped from Kansas City. An FW-190 crippled in combat often remained grounded for weeks, awaiting replacements that never came. The statistics became the Luftwaffe's obituary. In 1940, Germany had fielded 3,000 operational fighters. By January 1945, that number had fallen below 800. Fuel shortages left half-grounded. The rest flew brief, desperate sorties against bomber streams that darkened the sky. For Allied planners, the captured Focke-Wulf had provided more than technical insight. It had exposed the structure of an entire industrial system. They saw how Germany built perfection by hand, and they built functional immortality by machine. Captain Eric Brown summarized it years later. The FU-190 was a violin, the Mustang was a factory bell. One sang beautifully, the other never stopped ringing. The Luftwaffe's pilots fought bravely. But bravery could not replenish aluminum, nor replace factories turned to ash. Every Mustang that climbed from an English airfield was a symbol of what Germany could no longer match: endless capacity, endless supply, endless flight. The age of the artisan was ending. The age of the assembly line had already won the war above the clouds. By early 1944, the Luftwaffe's pilots began to notice something they could not explain. The sky, once theirs, was no longer familiar. Every tactic that had worked over France now failed over Germany. Every escape maneuver ended with contrails spiraling behind them. Mustangs and Thunderbolts climbing faster, diving longer, always there. At first, German intelligence dismissed the change as luck. Reports from Jagdgeschwader 26 described enemy pursuit aircraft with exceptional endurance and superior high-altitude performance. They believed these to be new models of Spitfire. But soon, reconnaissance photos revealed the truth. Sleek, long-nosed fighters escorting bombers all the way to Berlin. Their tails bore white stars. The Americans had done the impossible. By March, the P-51 Mustang was operating deeper into Europe than any fighter in history. It could fly 2,000 kilometers on internal and drop tank fuel, fight for 20 minutes over target, and return without refueling. Its climb rate equaled the WWII's best figures, and its ceiling surpassed even the latest German Dora variants. The Luftwaffe, once confident that range and altitude would protect them, had no sanctuary left. The psychological shift was immediate. Fighter Gruppen that once hunted over the Channel now flew defensive patrols over the Ruhr. When radar screens showed Allied bomber formations approaching, there was no question of intercepting them far from the target. The Mustangs would be waiting. Pilots took off, knowing the odds. 1 in 3 would not return. In diary after diary, the tone changed from pride to disbelief. "They are always above us," wrote Lieutenant Karl-Heinz Ossenkopf of JG2. "Always higher, always faster. Their planes never falter. Ours climb like old men gasping for breath." The FW-190 had once ruled by rolling faster than anything in the sky. Now its pilots found themselves outmaneuvered by aircraft that combined their own design philosophy with Allied power plants and range. The Mustang's laminar flow wings, refined using data from the captured German fighter, allowed it to hold energy in high-speed dives where the FW-190's control surfaces stiffened. During one engagement on April 8, 1944, near Brunswick, a group of 25 FW-190A8s attacked a bomber stream protected by P-51s of the 357th Fighter Group. The Germans dove through the formation, expecting to pull away in safety, as they had done countless times before. Instead, the Mustangs followed them down past 400 Miap, rolling level with perfect control. Within minutes, 8 Focke-Wulfs were burning in the fields below. At RAF and USAF briefings, officers quietly acknowledged what the Luftwaffe had not yet said aloud. The balance of air power had irreversibly shifted. Allied kill ratios soared. In February 1944 alone, the Luftwaffe lost 100 aircraft, more than in the entire Battle of Britain. Fuel rationing forced squadrons to limit flight hours. New pilots reached combat with barely 30 minutes of training in the FW-190. Against veterans flying Mustangs for their 3rd or 4th tour, it was suicide. Allied air commanders understood the moral weight of what was happening. They were dismantling not only the Luftwaffe's machines, but its faith in the air. The very instrument that had once given Germany its dominance, the fighter, was being used against it. Perfected by the enemy it had once terrorized. Captain Eric Brown later wrote, "You could see it in their flying, a hesitation that had never been there before. They no longer believed in their aircraft. Even at the top, the Luftwaffe's tone changed. In late 1944, General Adolf Galland, himself an ace with over 100 victories, told his staff, "The Mustang is the best all-around fighter in the world. We are fighting a mirror of our own design, perfected." The airfields of northern France and Germany were now filled with burned-out Fw-190s, some with their engines removed for lack of spares, others abandoned when fuel ran dry. Those that flew did so on synthetic gasoline that fouled plugs and robbed power. The war's industrial arithmetic had caught up with its pilots. For the Allies, the turning of the sky was more than victory. It was vindication. The captured machine that had humiliated them in 1942 had become the foundation of their triumph 2 years later. The very data gleaned from its dissection shaped the wings now sweeping across Europe. On the morning of D-Day, June 6, 1944, the German radar operators watching the Normandy coast could hardly believe the numbers. The air filled with thousands of Allied aircraft, Spitfires, Thunderbolts, Lightnings, and above them all, Mustangs. Fewer than 80 serviceable Fw-190s rose to meet them. In that moment, the Luftwaffe understood what every pilot had already felt in his gut. The sky no longer belonged to Germany. When the guns finally fell silent in May 1945, the wreckage of Germany's air force littered the continent. Twisted Fw-190 fuselages lay in fields from Normandy to Berlin, once the most advanced machines in the world, now scavenged for scrap. Among Allied engineers, there was quiet awe as they walked among them. Every bolt, every weld, every cooling fin told the story of a nation that had pushed technology beyond imagination, but not beyond defeat. At RAF Farnborough, the same hangar that had housed Armin Faber's captured fighter now contained dozens of German aircraft, Doris, Ta-152s, even early jet prototypes. But none carried the same weight as the original Fw-190A3 that had landed by mistake 3 years earlier. The test pilots called it simply Faber's Bird. It was still maintained in flying condition for comparison trials. By then, it was no longer a weapon. It was an artifact, the first domino in a chain that reshaped the skies of the war. The final intelligence report filed on the Fw-190 in late 1945 opened with a single line. The disorientation of one pilot on June 23, 1942, indirectly determined the course of aerial warfare in Europe. It was not an exaggeration. The Allied advantage that followed, the high-altitude tactics, the improved engines, the laminar flow aerodynamics, all traced back to that one intact machine. It had provided the technical vocabulary that allowed the Allies to read their enemy's language of design. Historians would later point out that the Fw-190 was never truly defeated in engineering terms. It remained an extraordinary machine, robust, deadly, elegant in its simplicity. What defeated it was scale, logistics, and adaptation. The Allies turned its lessons into production lines and doctrine, creating aircraft that were not just brilliant but numerous. Armin Faber himself spent the rest of the war as prisoner of war number 670 in a Canadian camp near Alberta. He was treated well, interrogated only once more, and eventually repatriated to Germany in 1946. In post-war interviews, he admitted that he never understood why his navigational instruments failed that day. "I was sure I was landing in France," he said quietly. "It was only when I saw the blue uniforms that I realized what I had done." The irony was bitter. The most decisive intelligence victory of the air war had not been planned, spied, or stolen. It had been delivered voluntarily by confusion and weather. Allied strategists later compared it to the capture of the German Enigma code machine, a single event that unlocked an entire system. The consequences reached far beyond the battlefield. The engineering data gleaned from Faber's aircraft informed the post-war jet era. British researchers applied its aerodynamic lessons to the early designs of the de Havilland Vampire and Gloucester Meteor. In the United States, North American engineers used it to refine the swept-wing theories that would shape the F-86 Sabre. Even the Soviet Union, through captured documents, absorbed fragments of that intelligence into the MiG-15. The FW-190's genetic code would echo in almost every fighter jet that followed. But there was a deeper human reflection in the story. The war had begun with the belief that superiority came from genius alone, that better machines and better men could impose will upon the world. The FW-190 embodied that faith. Yet its capture and analysis proved the opposite. Knowledge shared, multiplied, and industrialized was stronger than knowledge hoarded. The Allies had won not by creating a miracle of their own, but by understanding the enemies. In 1947, Captain Eric Brown was invited to fly Faber's FW-190 one final time before it was retired. He climbed into the cockpit, now marked with RAF roundels instead of black crosses, and took off over the Hampshire fields. It still felt alive, he later wrote. But this time, the sky belonged to the students, not the teacher. That FW-190 remains preserved in a museum today. The same aircraft that once ruled the Channel, landed by mistake, and changed everything. Visitors walk past its wings unaware that it carries in its rivets the blueprint of Allied victory. Its story is not one of humiliation or triumph, but of consequence, how the smallest human error can ripple through history. A moment of disorientation over Wales became a revelation at Farnborough, a revolution in Detroit, and a reckoning over Berlin. In the end, the war for the skies was not won by speed, by guns, or by courage, but by understanding. One pilot's mistake became every engineer's opportunity, and from it the Allies learned the most enduring lesson of all. Superior technology can dominate battles, but superior insight decides wars.